Hello everyone, it's Samir here, and today we are going to look at the problem of intersection of conics, okay, and a unique solution to that. So let's read the problem. It says the graphs of x square plus y square plus 6x minus 24y plus 72 equal to 0 and x square minus y square plus 6x plus 16y minus 46 equal to 0 intersect at 4 points. Okay, so it has given us two curves, two quadratic curves, and it has already stated that they are intersecting at 4 points. Okay, and it has asked you to compute the sum of the distances of these 4 points from a given fixed point minus 3 comma 2. Okay, so after looking at this problem, the natural instinct is that you find the intersection points of these two curves, okay, and find their distances from minus 3 comma 2 using distance formula. Okay, or better approach is, if you see that the first curve is a circle, so you can find its center, draw the circle. I have just drawn this for reference. Okay, and the second curve is a hyperbola, this one. Okay, so you can see that they are intersecting at 4 points, and you have to find the sum of distances of each point from the point minus 3 comma 2. Another better approach would be to use the symmetry. Since the center of both this circle and hyperbola lies on the line x equal to minus 3, so maybe using some symmetry, some calculations can be simplified. Okay, but still both these approaches are quite lengthy and involve a lot of calculation. The crux of this problem lies in observing the coefficients of the given curves, the circle and the hyperbola. You can observe that the coefficients of x square in both are same 1. The coefficients of y square are opposite, plus 1 minus 1. Again, the coefficients of x are same. So these three are the major observation points, because seeing that this, you can feel that if we add these two curves, okay, if you add these two curves, this minus y square and y square will get cancelled out. So if you will add them, you will get some quadratic in x and some linear in y. So you will get some sort of parabola, okay, because it's quadratic in one variable and linear in other. Okay, and next you can see that if we subtract one curve from the other, both x square as well as the 6x term will vanish, and you will just be left with a quadratic in y. Okay, so a quadratic in y will be just a pair of straight lines parallel to x-axis. Okay, so this is the major observation point. So once you observe this, okay, then you will get the real idea behind the problem, what it is seeking from you. Okay, so the core principle used in this problem is the curves of the type C1 plus KC2, okay, pass through the points of intersection of the curves C1 equal to 0 and C2 equal to 0. Okay, so whatever be the value of K, any curve of the type C1 plus KC2 passes through all the points of intersections of the curves C1 and C2. Okay, now why it is so? For some of the students who are not aware of this principle, so the principle is, suppose I'm just giving a simple example. Suppose if a point x1 comma y1 is one of the point of intersection of C1 and C2. Okay, so it will satisfy C1 equal to 0. Okay, and it will also satisfy C2 equal to 0 because it is lying on both the curves. It is the point of intersection. Okay, so if it is making C1 0 and C2 0, so C1 plus KC2 in the curve, the combined family of curves C1 plus KC2, if you put x1 y1, C1 will become 0 and C2 will also become 0. So the net will come 0. It shows that the curve x1 comma y1, the curve C1 plus KC2 is being satisfied by the point x1 comma y1. Okay, so any curve of the form C1 plus KC2 equal to 0, okay, passes through the same points of intersection of the curves C1 and C2. So for our case, we know that by adding these two curves and subtracting these two curves, we are getting simpler curves. Okay, so we can put k equal to 1 in one case and k equal to minus 1 in another case, to derive another set of curves which will be much simpler to deal with. Okay, so first we put k equal to 1. Okay, so putting k equal to 1, we can add these two equations. So adding these two equations, the given curves, we get 2x square plus 12x minus 8y plus 26 equal to 0. We will simplify it by dividing by 2. So by adding, you will get 6x square plus 6x minus 4y plus 13 equal to 0. So we complete the square in x to get the curve in standard format. So we see by making it a complete square, we add 9 and subtract 9. So it becomes x plus 3 whole square minus 4y, and 13 minus 9 gives you 4. So we rearrange it and try to find this curve in standard format, and we get x plus 3 whole square is equals to 4 times y minus 1. Now a standard form of a parabola is something like x minus h whole square equals to 4a y minus k. So in this standard format, h comma k is vertex of the parabola. So comparing with the parabola that we have got, the vertex of this parabola, this one, would be minus 3 comma 1. We are just comparing it with the standard parabola. Okay, and the part 4a is equal to 4 here. Okay, 4a from standard equation, in our equation is 4, so your a is 1. And we know that this is a vertical parabola, it is facing it will be facing vertically upwards. Okay, so the focus of this parabola would be 1 unit above this minus 3 comma 1. Okay, so its y coordinate would be 1 unit more than this. So focus of this parabola that we have got would be minus 3 comma 2. This is 1 unit, a units above the vertex. Okay, and now it's bingo moment, because this minus 3 comma 2, it is the same point from which all the distances were needed. This is the focus of the parabola. Okay, now we find the directrix of this parabola. Now directrix of parabola is a units below the vertex. Okay, for a vertical parabola. So the vertex is minus 3 comma 1. If you move 1 unit down, your y coordinate would be 0. So directrix is the line y equal to 0, which is same as x-axis. Okay, so this is the information that we get from the curve by adding the two given curves, which came out to be parabola. Okay, now we subtract the curves by putting k equal to minus 1 to get our other curve. Okay, so our other set of curves by putting k equal to minus 1. Okay, so we subtract the second equation from the first one, and we get 2y squared minus 40y plus 118 equal to 0. We simplify it and we get it y squared minus 20y plus 59 equal to 0. It is not containing any term of x. Okay, as of now you don't need to solve it. If it's needed, we will do it later. So this is going to give you a pair of lines parallel to x-axis. If you will factorize or solve the quadratic, you will get two lines of the form, this will be factorized something of in the form y minus y1 into y minus y2 equal to 0. And y equal to y1 and y equal to y2 will be the two lines represented by it. So our new set of two curves is, one is this parabola that we got, and one is these set of parallel lines parallel to x-axis. Now we'll need to just simply draw this. Okay, so drawing this is easy because this is just a simple parabola facing upwards with the vertex minus 3 comma 1. Okay, so we just draw this parabola. Okay, so we can see that this is a parabola with vertex at -3, 1. Its focus is -3, 2. And for these lines, we don't need to find the exact lines as of now. We know for surety, because it is given in the problem, that they intersect at 4 points. So we just draw 2 lines above the parabola. So they are intersecting at 4 points. Okay, this B, C, D and E. Okay, so our next part is just to find the distance of each of these 4 points from the focus -3, 2. Now we can use the property of a parabola, okay, which is distance of a point from focus is its distance from directrix. Okay, distance of a point from focus is its distance from directrix. Okay, so the distance of this point from focus would be its distance from directrix, which is x-axis in this case. So we'll just need to find the y coordinates of these points, because distance from x-axis is the y coordinate of a point. Okay, so like joining these points to the focus and directrix, we would get a figure like this one. Okay, so we need the sum of distances of all these 4 points from focus. So say this distance from point E to focus, this distance would be equal to this distance, its distance from directrix. Similarly, this distance would be equal to this distance, and so on. Okay, so finally we just need to find these vertical distances, or sum of these distances rather. Okay, and what are these distances? These are just y coordinates of these 2 lines. Okay, because these lines are the 2 lines represented by this are passing through here. Okay, and also you notice that the distance of point C from x-axis would be same as distance of B from x-axis, because this line is parallel to x-axis. Okay, so we do the remaining calculation here. So the point C and B, we say that their distance suppose is y1. Okay, and okay, because we already saw that these 2 distances would be equal, and we suppose that their distances are y1, this one, and the distances of point E and D, point E from x-axis and D from x-axis would also be equal. We call it y2. Okay, so we name them as y1 here and y2 here. Okay, so now the sum of these 4 distances will be y1 plus y1 plus y2 plus y2. Okay, which would be 2 times y1 plus 2 times y2, which is 2 times y1 plus y2. Okay, now from the equation that we had, okay, so y1 and y2 are roots of this equation. Okay, y equal to y1 line and y equal to y2 line. So we don't even need to find these y1 and y2 separately. Okay, you just need their sum, and sum of roots from a quadratic is its minus b by a. Okay, so minus b by a of this quadratic is minus of minus 20, which is 20 upon 1. So your answer would be 2 into 2 from here, and y1 plus y2 would come out to be 20. Okay, so your answer here, we will take 20 from here. So 2 into 20, y1 plus y2 is coming out to be 20. So answer is 40. Okay, so your sum of distances of all the 4 points from the point -3, 2 is 40. Okay, so this problem was never about finding, the coordinates of all the points or trying to solve out anything. It was just about seeing the coefficients of given figures and trying to figure out what it is exactly wanting from you. The crux was that -3, 2 came out to be the focus of parabola, which was derived from these 2 curves. Okay, so for more such problems and more such ideas and solutions, keep watching. We'll see you in the next video.